The next set of material that we're going to look at is rational expressions. In this section, we're going to do an introduction, including talking about undefined spots, as well as simplifying rational expressions. So, in order to complete this section, make sure that you understand the rules for simplifying fractions. And you need to be able to factor and solve polynomial equations. So what is a rational expression? A rational expression is the quotient of two polynomials, which is a fraction containing variable terms. One of the first things that we want to talk about is values that create undefined expressions. Recall that a fraction is undefined if the denominator is equal to 0. When variables are included in a rational expression, it becomes critical to find values that create an undefined expression. In future math classes, you'll see several phrases that refer to this exact concept. The first one you will see is restrictions. Restrictions refer to numbers that are not allowed, in this case where the denominator is equal to 0. In the next math class, you will learn about the domain of an expression or equation. The domain refers to all possible values that are allowed. Numbers that create undefined spots would not be considered part of the domain. In order to find what values will make an expression undefined, we want to know when is the denominator going to equal 0. So we're going to set the denominator equal to 0 and solve for x using either linear or quadratic techniques. Let's look at example A. The first thing we want to do is set the denominator equal to 0. We get 7x minus 28 equals 0. From there, we want to solve for x using linear techniques. This will involve add 28 to both sides. Then we can divide by 7. The result is x equals 4. Now, if we note the first note at the beginning, it says finding undefined spots is not the same as solving equations. Since we are examining expressions, you need to state that what you have found is a number that will produce an undefined expression, not a solution. So for example A, we want to go ahead and say when x equals 4, the expression is undefined. Let's look at another example. Again, in order to figure out where this is undefined, we're going to set the denominator equal to 0. We get x squared plus 3x minus 10 equals 0. Since this is quadratic, we will need to use quadratic techniques. So we will want to factor and set each factor equal to 0. If we do this, we get things that multiply to 10 is 5 and 2. They do subtract to 3. We want our larger quantity to be 5. That means that we want our larger quantity to be positive. We'll make the 5 positive and the 2 negative. From there, we want to set each factor equal to 0. We can go ahead and solve x plus 5 equals 0 by subtracting 5 from both sides. We get x equals negative 5, and in the second one, we get x minus 2 equals 0. We can add 2 to both sides, and we get x equals 2. Again, remember that we want to state that what we are finding is areas where the expression is undefined. So when x equals negative 5 or positive 2, the expression is undefined. If we look at example C, since the denominator is a whole number, it will never equal 0. 12, never going to equal 0. So there are no values of x that will yield an undefined expression. This expression is defined for every value of x. Another thing to note is when finding undefined spots, the numerator is not relevant. It can be whatever it wants. We'll see when we'll need it when we start simplifying fractions or simplifying rational expressions. But in terms of what we're doing right now, as I said, we just ignore it. The numerator has its own special meaning, and you will learn about this in future math classes. Let's review how to simplify a fraction containing numbers. If we look at the first example, 27 over 30, we can divide the top and bottom by 3, giving us 9 over 10. What are we dividing by? We refer to this as the GCF, or the greatest common factor. Keyword being factor. For more complicated fractions, remember that one of the things we did was use prime factorization. We can factor 26, we can factor 91, and notice that we were going to cancel the 13s, leaving us with 2 over 7. When working with rational expressions, we want to use the second technique. We want to cancel common factors and write what remains. Before we can cancel common factors, though, we do have to factor both the numerator and the denominator. Just like with the more complicated example, you can start with the easier polynomial and use the factors to help you factor more complicated polynomials in the problem. Our procedure in order to simplify a rational expression. Number 1, we want to factor everything completely. From there, we want to cancel common factors. Remember that factors are things that are multiplied together. You cannot cancel things that are being added or subtracted. Also note, if factors are exact opposites of each other, for instance, a minus b and b minus a, you can factor out a negative to make them the same. Finally, we are going to write what is left over in factored form. Let's look at an example to start us off. Example A, we have 5x plus 35 over 20x. The first thing I want to do is factor out the GCF from the numerator. GCF is 5. If we do this, we get 5 times, divide each term by 5, we get x plus 7. Denominator, we can leave it the same for now. From there, we want to cancel the common factor. Note that 5 and 20 are both divisible by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. So now what do we have left over? In the numerator, we have x plus 7. In the denominator, we have 4x. This completes the problem. Let's look at something a little bit more challenging. Again, my first step is I want to factor out the GCF from the numerator. In this case, the GCF is x squared. If we factor out x squared, inside, we are left with x plus 1. The denominator stays the same, and now we can cancel out the common factor of x plus 1. It is exactly the same, and we are left with x squared. Note, we no longer have anything in the denominator. It's implied to be a 1, but anything over 1 is itself. So our final answer is x squared. Looking at example C, again, we want to factor the numerator and the denominator. One thing I note about this problem is the denominator is difference of squares. So let's start with that since it's easier. X squared breaks down to x and x, 25 breaks down to 5 and 5, and we have different signs. From there, I can use one of these factors for the numerator. Remember, the goal is to cancel common factors. If we look at the numerator, we have a positive 5. To multiply to a positive 5, we want same signs. The middle term tells us what they are. They are both positive. So x plus 5 is the only option that would make it possible for us to simplify the rational expression. So let's let one of the factors be x plus 5. If we do that, the other one would have to be x plus 1, because 5 breaks down to 5 and 1. We can cancel x plus 5's. What we are left with is x plus 1 over x minus 5. Note, you cannot simplify any further than that because we no longer have anything being multiplied together. Let's look at example D now. One of the first things I notice is the denominator is in the wrong order. So let's start by flipping the terms around in the denominator so that it is in descending order. We get negative 6x plus 15. From there, we want to go ahead and factor the top and the bottom. The numerator is difference of squares. So 4x squared breaks down to 2x and 2x. The denominator the 25 breaks down to 5 and 5. We have different signs. In the denominator, we can factor out a greatest common factor of 3. I'm also going to factor out the negative so that we can get a common factor again. If we factor out a negative 3, we want to change the signs of the terms inside the parentheses. We get 2x minus 5. And now we can cancel 2x minus 5 from the top and the bottom. What we are left with is 2x plus 5 over negative 3. And that's it.